Okay. So we're preparing to do second order differential equations. So we need to make a little review of linear algebra and some other properties of functions. Okay. So and then once we get this, it's gonna be easy to find our main theorem. So it's gonna be helping us to solve equations of the form a2x y prime x plus a1 of x y prime of x plus a0 of x y equals to 0. Okay, so all that we're doing is going to prepare us to solve this kind of equations. Okay, the second order differential equation. Okay, so we will have a theorem that basically tells us that all that we need to do is a quadratic formula. Okay, so please be patient while we set up all these results and definitions. So definition. So this is an important definition. So definition is linearly dependent or independent. Linear dependence. So let's say two functions f of 1x and f of 2x are said to be linearly independent. Linearly dependent on an interval I. So all of these have the same domain. So the interval I is the domain of f1 and f2. If there exist constants C1 and C2, not all 0, such that C1 f1 of x plus C2 f2 of x equals 0 is happening. Okay, so you can find C1 and C2 such that the sum of the two functions is gonna give you 0. Okay, so that's, for example, that's equivalent to say the vectors. Okay, so for example, you got two vectors. Let's say, well, let's get two vectors on the same line. So let's get 1 1, and then another vector in the other line is let's say minus 2 2. Okay, so you have minus 2 2, and then you have here 1 1. So are they linearly dependent? Yes, because you have 1 1, so you need to find two constants such that this minus 2 1 1 minus 2 minus 2. Yeah, minus 2 minus 2. So you need to find two constants C1 and C2 such that that sum gives you 0. So what will be one constant? What will be possible two constants for that? So C1 could be what? C1 could be 2 and C2 could be 1. So you have 2, you'll get 2 2 plus minus 2 2. So that will give you 0, you see? So that's what is called linearly dependent. But we saw last time that if you find the determinant, if the determinant of these two things is 0, they are linearly dependent. For example, let's do this one. So 1, 1, and minus 2, 2. This is 1 times 2, and minus 2, right? 1 times minus 2, minus 2. Minus 1 times 1, minus 2. So this is 0. So you see, so the determinant helps me to basically to make my life easier, and I don't have to think too much. So I just find the determinant. If this 0, they are linearly dependent. So they are in the same line. So for functions, you see, you don't have determinant, and you could try to find these constants, but so there is a proposition somewhere where it says that if you need to find the f1 is linearly dependent of f2 if and only if the Roskian, or at least the Roskian is going to be 0. Okay? And what was the Roskian? We said already that the Roskian was f1, f2, and then we got to do f prime, f2 prime. Okay? And this is the Roskian. Let's put it like this. The Roskian of f1 with f2 is the determinant of these two guys. So you got f1 times f2 prime minus f1 prime times f2. Okay? So if they are 0, they are linearly dependent. If it's not 0, they are linearly independent. Okay? So we'll do more examples of that soon. Because I kind of want to move on to the to other definitions. So if you have this is definition. So remember, in our objective right now is to find solutions for the second order. Okay. So I'm going to focus just in functions of second order. So we're going to definition fundamental solution. Okay, so and this is any set y1, y2 of linearly independent. So any set linearly independent solutions of the equation. So let's put it a2x second y prime of x plus a1 of x. So this is also depends of x, no? Y prime of x plus a0 of x y of x equals to 0. Any set y1, y2 of linearly independent solution of this equation is a fundamental solution. Is a fundamental well, any set or linear okay, it's a fundamental set of solutions. Well, so how this is really gonna work? So if you have what it really means, or how we're gonna use it is, let's say you have a solution y of x to this equation. Okay, this is a solution of that. if there are two linearly independent solutions, then you should be able to write this solution as a combination of these two solutions for some constants. So that's why finding two independent solutions is so important. So you find two independent solutions, so you will find all possible solutions. Okay, this is because it's linear. This is not true when equations are not linear. For example, if I have here, for example, y squared, that's a nonlinear equation. This is not true. So it has to be linear. So you guys probably everything you might do nonlinear differential equations in your classes of maybe some equations of dynamics or fluid dynamics, and the way you will solve it probably will be numerically, okay? Because this theorem doesn't hold, and this theorem is fundamental. Okay. Sometimes what they do is linearize the differential equation. So you make approximations and then you treat it like this theory. Okay, so this theory is fundamental. Is the theory. This is equivalent to make limits in calculus and all that. This is how explaining you how do you find solutions. Okay, so the general solution, this is called the general solution. Sorry, let me put this one. This is called general solution. And what we will see is that basically they're gonna come out from quadratic formula. Okay, so that's what we learned in high school. But it has to be homogeneous. Okay, so it's homogeneous when it's equals to 0. Let me make that 0 bigger. So this must be equals to 0. This is called homogeneous. If it's not equal to 0, then this is different. Okay, so you don't have to. This is not gonna be true. Okay. So, okay, so that's the way we find general solutions. So, so let me finish doing a Roskin. So to finish this first part of the preliminary theory for differential equations of segundo order. So we're gonna do the Roskin in general. So definition of Roskin. So it helps you for your homework. Definition Roskin. So the Roskin of, let's say, 3 functions. So the Roskin of 3 functions will be the determinant of each function, then the derivative of each function, then here the second derivative of each function. Okay, so you want to see if 3 functions are linearly independent. So then you'll have to do that, verify that this determinant is different of 0 to be linearly independent. Okay, if you want to check 4 functions and so on. But let's see. So what do I need? 3 functions. So if I want to do 3, if I want to find 3 independent functions, it's because the equation should be the 3rd order. Okay. So that will be if I have a 3rd derivative. Okay. So a3x plus a2x second y prime a1x y prime plus a0x y equals to 0. Then you will need to find three linearly independent functions to find a general solution. Okay, so a general solution will look like y of x equals c1 y1 of x plus c2 y2 of x plus c3 y3 of x. Okay, so that will be, so this is important. So if you have degree 3 derivatives, then you need 1, 2, 3 linearly independent solutions to find the general solution. If you are degree 4, you will need 4 linearly independent solutions. Okay, so that's the general theory for these solutions. So now, suppose you find one solution and you want to find a second one linearly independent. So this is correspond to a new section. So we're going to do a new formula here. So it's called reduction of order. Reduction of order. Basically means, I mean, well, the way we're gonna use it is given one function, I can find a second one linearly independent. Okay, so, and this is the way you find it. So if y1 x is a solution in this case of a second order differential equation, how can we find the other solution? Linearly independent. Okay. So I'm gonna give you so it's basically an equation. So we could derive it, and it's for a method called variation of parameters. But I'm not gonna do that part yet. We're gonna do it later, like in 4 more classes or something like that. So I'm just gonna tell you where is the formula coming from. Or what I'm gonna tell you just the formula. I'm not gonna tell you where it's coming from. Later we will prove it. Okay. So y2 of x is gonna be equals to y1 of x integral of. Okay. So let me write the equation. So the equation looks like this: second y prime plus p of x y prime plus q of x y equals to 0. Okay, so you have one solution for this guy, right? So y1 of x is a solution of this guy. You want to find the second solution. So the second solution is like this: y1 of x that e to the negative integral of p of x dx over y1 square of x dx. Okay. So we will see where is this coming from, okay? But for now, you can just trust me. So let's make an example. So we will use this very soon, like in 20 minutes. And then you will understand, and then we will develop this really important theorem that will make our life really easy to find this second order differential equation. So in general, second order differential equations could be even easier than first differential equations. Okay. At least homogeneous. When it's not homogeneous, well, we have to do something else. But so let's see. So let's say let's assume that. So let's assume we have one solution. So given that y1 of x equals e to the x is a solution of second y prime minus y equals to 0 on the interval minus infinity to infinity find a second solution y2 of x. Okay. So what are we gonna do? So we use this formula over here. So y1 of x, so solution so let me y1 of x is e to the x, right? So therefore, let me move it here so I can keep going. So y2 of x will be equals to y1 of x, that is e to the x, integral of e to the minus integral of p of x. So what do you think will be p of x in this case? Our equation is this one. Somebody else? Another opinion? Because this one is y, right? So this is y. This is y. This is second y prime. So what is p of x? No. So p of x is 0, right? Because I don't have y prime. You see? I don't have y prime. So p of x is 0. So p of x, yeah, but thank you for answering, because that's it's important for you. You're not gonna make this mistake in the exam. If you don't even try to answer, you probably are gonna make the mistake in the exam. You have to try to think when I ask it. So p of x is equals to 0. So it will be, following the formula, is e to the minus 0 dx, okay, over y1 square of x. So y1 is e to the x, right? So y1 of x is e to the x. Therefore, y1 square of x is e to the 2x. So this is e to the 2x and then dx. So here we can just choose the this to the 0, right? So this will be, so this will be, we could just choose to be, so the integral of a 0 could be a constant, okay? But I'm just gonna choose it to be the constant 0. So this cancels. So I get e to the x over 1 over e to the 2x dx. Okay? So I put this on the top to get e to the x integral of e to the minus 2x dx. Okay? So what is the antiderivative of e to the minus 2x? So e to the minus 2x divided by negative 2. So I will get e to the x times e to the minus 2x is e to the minus x divided by minus 2. Which one? This one? Because the formula says y squared over y squared. It's it? Y squared. So y squared of x is e to the 2x. It's for the, yeah, for as long the solution looks, the equation looks like that, that's your formula. To find the second solution, and you have one solution. Okay? So that's your function. So let's check that this is correct. Let's check it works, because so far it's just faith, right? So the supposedly y2 of x, sorry, let me put this one. y2 of x, y2 of x, y2 of x. So y2 of x must solve this guy, right? So y2 of x is e to the minus x over minus 2, right? So first derivative of y2 of x is, what is the first derivative of that? Second? Yeah, so we put this, will be e to the negative x, and the minus 1 half stays there, times the inside, the derivative of the inside, that will be times minus 1. Right? So that will give me e to the minus x divided by 2. But I need the second derivative, right? So a second derivative will give me minus e to the minus x divided by 2. Yeah? And now the other part of the equation says minus y. So minus y2 of x, my original, that will be e to the minus x divided by 2. So the equation is saying that second y prime minus y equals to 0. So we are replacing, right? So the first one is this minus the second one, that gives me 0, right? So this plus this is 0. So y2 of x is a solution of this equation. Okay? So that's a solution of that equation. So this is indeed a solution, but is a linearly independent solution. So how can we check? So are y1 of x and y2 of x linearly independent? So what should I do to figure out they are linearly independent? So y1 of x is e to the x, right? And y2 of x is 2e to the minus 2x. Is that? Oh, yeah. No. Minus. Yeah. So those are my two functions. Let me check how much time I have. Yeah, 30 minutes. Okay. So are they linearly independent? How can I check they are linearly independent? Take the Roskian. So we need to do Roskian of y1 with y2. Or if you want, a Roskian of e to the x minus e to the minus 2x, divided by 2. So we do the Roskian. So what is the Roskian of this? So you put the two functions, e to the x minus e to the minus 2x divided by 2, and then find the derivatives, right? So what is the derivative of e to the x? E to the x. And what is the derivative of this one? Yeah, so we will put minus 2 down. So e to the minus 2x, and we put the minus 2 down, that will be minus 2 times minus is 2, right? Divided by 2 is just 1. So it stays like this. Now we found the determinant of that. So e to the x times e to the minus 2x minus e to the x times minus e to the minus 2x divided by 2. So that gives me e to the minus x and minus times minus plus, right? So what does it give me? E to the, what is e to the x times e to the minus 2x? E to the negative x, thank you. Divided by 2. So what is e to the minus x plus e to the minus x divided by 2? What is that? So this is plus, right? So 2 by 2, so that's 3/2 e to the negative x. Is that 0? No. So they are linearly independent. Okay? So that's the, we can stop this video here. So that's the end of finding Roskian of independent functions, and also finding a second linearly independent solution.